In real life, fractions and decimals are used to represent weight, money, temperature, time, length, and distance. We often find data represented by fractions that would be easier to work with if they were decimals. You know that 1/2 is one whole cut into 2 equal shares. So 1/2 means 1 divided by 2. And 1/4 means 1 divided by 4. So you can use division to write any fraction as a decimal. 1/2 means 1 divided by 2 or 0.5. 1 divided by 4. 1/4 is 1 divided by 4 or 25 hundredths. And 3/4 means 3 divided by 4 or 75 hundredths. You can verify that each decimal quotient is correct by multiplying the quotient by the divisor. For example, 1/4 is 25 hundredths, and 25 hundredths times 4 equals 1, or 3/4 is 75 hundredths, and 75 hundredths times 4 equals 3. The decimal number for each of these fractions has only 1 or 2 digits after the decimal point, but the decimal for some fractions have many more digits, and some never end at all. Look what happens when you divide when you divide to find the decimal for 1/3. You get 0.3333 repeating. In this lesson, you will find out about terminating decimals, such as 0.25, and repeating decimals, such as 0.3333, which never end but repeat the same digits over and over and over. Like me, I repeat over and over and over. Describe how you could find the decimal that is equivalent to 3/15 without using long division. So if I look at the fraction 3/15, I notice that it's not simplified. So I'm going to simplify it because I can divide by 3, and I can divide by 3 on the numerator and denominator. So I find that I can simplify that, and it's 1/5. 1/5. What can I do with that so that it looks like something that would be easy to change to a decimal? Well, I know that if it's over 10, it's easy to say as a decimal, easy to write as a decimal. So if I multiply the numerator and the denominator both by 2, it's going to be a whole lot easier for me. So if I can multiply and I get 2/10, then I can read it as 2/10. If I say that in my head, 2/10, then I can write it as 2/10 as a decimal. Oh, there. I did it. I changed it to a decimal without ever dividing. Then I'm done that problem. You can use fraction strips to visualize the numbers. The fraction strips show each of these fractions is 1/8 more than the previous fraction. You can also use a table of values to help show the relationships. Look for a pattern and think about the decimal forms of 6/8 and 7/8. So if you look at the pattern that they show you the division, and then they also show you the pattern that follows. And if you look at it, they're adding 125 thousandths each time. So if I follow that pattern, I know that the next number is going to be 0.750, and the number after that is going to be 0.875. And I still haven't divided anything. Describe the pattern in the decimal numbers in the model it and tell how the numbers change and why. So the pattern in the numbers, the numbers increase by 0.125. And why? Because they go up 1/8 each time. extend this pattern to write, and we did that. Explain your thinking. I added 1/8 each time. Now, in the chart, write the decimal form of each fraction of the fractions. They already told me what the decimal form of 1/8 is, and they told me it was 0.125. They already told me what the decimal form of 1/4 is on the first page. They told me that it's 0.25. I'm going to put a 0 after just so I have the same number of digits in all my numbers. They already told me what the decimal form of 1/2 is. They told me that it's 0.5. I'm going to put 2 zeros after just so I have the same number of digits. Now, let's look at a pattern. Let's look and find a pattern. I have 0.125. Pretend there's no 0 point on the front. And let's look at that. I have 125. I have 250. And I have 500. So can you find a pattern between 125, 250, and 500? If I multiply by 2, 125 times 2, I would get 250. And then 250 times 2, I would get 500. So adding that decimal point in there, how would I get that? So if I take 1/8 times 1/2, if I take 1/2 times 1/2, I get 1/4. And if I take 1/4 times 1/2, I get 1/8. Okay, so explain how you could get from one row to the next by multiplying. Well, we just did that. So 1/2 times 1/2 equals 1/4. And 1/4 times 1/2 equals 1/8. 1/4 times 1/2 equals 1/8. Explain how you could build on knowing the decimal form of 1/5, which you found in Reflect to find the decimal form of 3/5, and then write the decimal. So if we know that 1/5 is equal to 2/10, how could we find the decimal form of 3/5? So if we know that it's 3 times more, all we'd have to do is multiply by 3. So if we know that 2 times 3 is 6, we put in the decimal point, so we have 0.6. We have 6/10. Isaiah knows that 1/4 is written as 25/100ths as a decimal. How can he find the decimal form for 5/4 without dividing? Well, if he knows that it is, it's the same as a quarter, right? If I have 1/4, and that's 25 cents, what is it worth if I have 5 quarters? And that's worth $1.25. What's another way he could do it without dividing? He could say that 25 times 5 equals 1.25. On the next one, on this one I actually have to do some division. So I have 2 divided by 6. So 6 goes into 20, 3 times. That's 18. 2. Oh, I'm going to start repeating again. So here I've got 0.3 repeating. On the next one, I've got 4 divided by 6. That goes in there 6 times, 36. Here again, it's going to start repeating, so I've got a repeating 6. Now I've got 5 divided by 6. This one goes in here. Okay, so 6 goes into 50. That goes in there 8 times. 48, 20. 6 goes into 23 times. 18. Now my 2 is going to start repeating. So 8 and 3 don't both repeat. Just the 3 repeats, so only the 3 gets the bar. So I've got 0.83 with the bar over the 3. Now my table is all filled out. Continue the work of division on 1 divided by 6 on the previous page for 2 more decimal places. What do you notice? Okay, so if I go here and they wanted me to continue, what would you have noticed? Well, I already know what it's going to do. I know that it's just going to keep repeating that 6. What do I notice? I notice that the 6 continues to repeat. Explain why the decimal for 1/6 is called a repeating decimal. It never ends. Complete the chart on Model It and explain the relationship between 2/6 and 4/6. Well, let's go back. If I look at 2/6 and I look at 4/6, well, I have a repeating 3 and a repeating 6. What's the relationship there? Well, 3 times 2 is 6. So the relationship between 2/6 and 4/6, 2/6 is half of 4/6. Divide 1/9 as a decimal. Divide to write 1/9 as a decimal. Oop. So I'm going to divide this. I don't want to do that far up. 1 divided by 9. Okay, how many times does 9 go into 10? Well, that goes in there once. 9, 1. Oh, look, it's going to start repeating. So I know I'm done. So I've got 0.1 repeating. How can you use that fact to write 3/9? How can you use the fact that 1/3 equals 3/9 to write the decimal for that? Well, I know that 3 divided by 9, I know that's going to be a repeating 3. So I know that this is a repeating 3. I know that 1/3 is going to be a repeating 3. Because I know that anything over 9 is going to be that number repeating, because that's the trick of the 9s. So what is 4/9 going to be? Well, I know that that's going to be a repeating 4. For 12 over 9, I can't do it that way, because it's not a proper fraction. I have to simplify that first. I have to change it to a mixed number or a fraction. I have to change that because I can't do a fraction greater than 1. How many times does 9 go into 12? Well, that goes in there once, and I've got 3 left over. Now I can do that fraction because I have 1. Then I put my decimal point. Now I can do the repeating 3. And I'm done.